Welcome back to the second part of the Pixel Walls demo. If you remember last time, where we got to was creating this little puck character that can move up, down, left or right with the W, A, S and D keys. And I've got the sketch here on the computer and I can show that running. If I just need to click into the screen, I can show that running, so it's going left, right, up and down. But the problem at the moment is that it can also go through the walls. So what I'm going to show in this demo is how to stop that from happening. And basically what I'm going to do is check the color of the pixel behind the center of where the puck wants to move to. So if the puck is standing somewhere and it wants to move left, it will only move to the left, which is, for you, it's that way, right? It'll only move to the left if that space is clear. But if you want to go to the right, it won't move there if the space has a black pixel. So I'm going to show how to set that up. Now the key is that we need to think about how we set this drawing up in the first place. And you may have noticed from watching the puck move around on the screen that there's sort of a grid set up behind the scenes of this picture, so that the puck is always sitting perfectly aligned on this grid. And all of the walls are also drawn on the grid, so that we can use this so that when the puck moves to a position, we just check the pixel at the center of that grid. And if it's clear, that means the puck can move there. But if it's not clear, then the puck can't move there. So I'll show you now how to set that grid up in a program like Illustrator. So in the background here, I've got Illustrator running, and I'll upload this this file to the sketch folder so that you can download it and alter it for your needs. But you can see basically what I've set up is 3 layers. The first layer just has all of these rulers on it, and they're just spaced out at 20 pixel intervals. And the easiest way to do that, I'll just show you how to set that up, is if I just delete these rulers at the top. Many of you may not have used Illustrator before. It's available on the university computers. So the easiest way to set this up is to go into View and then go to Rulers, and then it'll be hidden by default. So you just make sure that you can see the rulers. So choose Show Rulers, and that makes these things along the edge show. And then drag a ruler out and align it with the left side of the page. You can see the little pink text appears there. And then what you do is just click and drag a little rectangle over the ruler so it highlights. You can see it's highlighted red there. And then go into Edit, Object, and then Transform, and click on Move. And for these vertical rulers, we want to move them to the right. So I want to move it by 20 pixels. But I don't want to move them up or down, so I can set that second one to 0. And you can click this little thing here, Preview to See. Yep, so you can see it moves across when I do that. And then the trick is to click Copy. So if I copy, and then I can press Command and D, or the equivalent on Windows, and just copy that across the screen, and I'll get this grid of perfectly aligned rulers. There'll be lots and lots of YouTube videos on how to set that up if you need a more detailed intro, or in a program like Inkscape is a free alternative to Illustrator where you can do similar things. So once that's set up, then just make sure that the walls are drawn so that they always go on those rulers. So you can draw any shape wall you like. So if you take the pen tool and just copy the the style of that wall. Like if I wanted to draw, say, a wall at the top here, I can just click, and as long as I keep the wall on those lines and only going sort of up or down, this technique will work, right? Last year when I showed students this technique, some of them didn't pay close attention to setting this grid up properly, and it didn't work for them. So you've got to be a little bit careful about this. But so 20 pixels apart, or whatever grid size you want, and make sure that all your walls are on the grid. All right, and then once you've done that, just save your drawing so you can export it, export for screens. Click the artboard, and we're going to save it as a PNG. And I'm just going to save it to my desktop. Yep. Choose that and export the artboard. Right, so I'm going to quit out of Illustrator. I'll save that. I also had a layer in there for the puck, just to show where the puck is, but you can ignore that layer if you do download the file. So if I'll just minimize that. And Adobe Illustrator has saved it in this 1x file. I don't really want it in there. But there's the file I just saved. And if you open it up, you should see it's like this. Now, I saved it as a PNG so that the background would be transparent. And I'm going to use that. So either a pixel is transparent or it's black in this case. And that's what I'm going to check. All right, so from last time you should remember that's already loaded into my sketch and it's running there. And just to show you that the background is transparent, I'm going to change the draw function so that instead of setting the background to this gray color, I'll set it to red, and then you'll be able to see which parts of the walls of that background are transparent. So you can see all of the gray the parts that were gray before, they're the transparent parts. Okay, so the first thing I'm going to do is show how to check that the pixel is what transparency it has. So if we go into the puck class, and then in this move function that we created, at the moment I'm going to do it after we move. I'm going to say let C for color, this is just a temporary thing, C equals BG, which is the name of the image that's holding the image variable that's holding the background. BG.get this.x, this.y. Now, if you remember from the tutorial on images, with an image you can use this method get, and it will give you the pixel color of the pixel at that position. So this is going to give me the color at X and Y. And what I'll do for a start, I'll just console log that color value so you can see what we get. So if I run this again, when I move, I should see the color of the pixel that the puck is over on the console. So let's see. So there you can see it's 0, 0, 0, 0, 0, 0. And then when I go over a wall, I should see something different. Yeah, so I get 4, 7, 7, 255. Now notice that this wall is black, but it's not completely black. It's a very, very dark gray. It's like 477. But the crucial thing is that its alpha value, the fourth argument to the color function, is 255, which means it's completely opaque. Whereas the other pixels, where it says 0, 0, 0, 0, that last 0 refers to the transparency level, the alpha level. And for those pixels, it's 0. So that's what we're going to compare, just that last one, whether it's 0 or 255. So just to make that a bit clearer, I'm going to say let A for alpha equals alpha of C. And I'll console log the alpha instead of C. So now when I move, I get 0, 0, 0, 255. So let's use that to stop the puck from moving over a wall. Have a quick think about where in the code would we need to do this check. So if you look up here in this move function, on line 11 and 12, we're actually taking the arguments amount x and amount y and using them to change the position of the puck. But really we want to check whether that is a safe position to move to, right? Before we actually change this dot x and this dot y. So we need to have the check above line 11. So we're going to move line 11 down and put in a check before that to see whether it's actually okay to move. Right, so just here I'm going to be using these numbers that I've been getting for the alpha, but I'm going to say let C equals BG, the image BG, get this dot x plus amount amount x, and this dot y plus amount y. A equals alpha C, and then instead of just logging it to the console, I can say if A is exactly equal to 255, then it's not okay to move there because that's an opaque pixel. So I'll say console.log can't move there, buddy. Else, well, otherwise it's safe to move there. So I'm just going to update the this.x and this.y. Let's run that and then see what we get. So if I click here, oops. That's not what I expected to see. Let's see. The problem was I had the caps lock on my keyboard. I'd accidentally pressed that, and here my checking is a little bit crude. I'm checking just for a lowercase w. So it's probably a good idea for me to say if key equals w or key equals a capital W. And I'll putting in the three equal signs just as a more kind of robust check. So let's do that. A. I'll just copy and paste this to make it a bit quicker. D. S. Put in the extra lines there. Okay. So lowercase a works and uppercase a works. Okay, that's good. Right, so now when I try to move over this wall, we should see just in the console, just down there, we should see this message, can't move there, buddy. Let's try it out. Can't move there, buddy. Can't move there, buddy. Can't move there, buddy. Now, what about moving like down? So I'm pressing the S key there to try and move off the screen. And even though there's no pixel there, it's still actually saying can't move there, buddy. So I'm sort of interested in that. Let's see what values we get from that color function when we're trying to move off the canvas. So just once again, I'm going to console log the alpha. Okay, so go across to the left-hand side. So it's the alpha that's being logged to the console. You can see there is 0. and then as I move off, it's going 255, but I have actually gone right to the edge there, so I don't want that. What happens up here? So it is still 0 there, but it's 255 if I try to keep moving up. And there it's 255, so I can't move off the bottom. So I think what I need to do here is actually also check not just if the alpha is 255, but also, or if this dot x, and I'm going to make a variable here, let new x equals this dot x plus amtx, and let new y equals this dot y plus amty, and then use those variables for the test here. And when I update, I can just say this dot x equals new x. And I can also use that variable here. If new x is, let's say, less than or equal to 0, right? I can't move anything less than or equal to 0, and I also can't move anything less than or equal to 0 in the y direction. So I think with those extra 2 tests, if any of those 3 things are true, we should not be able to move there. So can't move into the wall, and I can't move to somewhere where x is equal to 0, and I can't move to somewhere where y is equal to 0. And on the other side of the screen, let's give myself some extra room here. Move all the way over. I can't move off the right-hand side, and I can't move off the bottom side. Okay, so this technique works, and I think people find it easier to understand than some other ones because you can think in terms of these pixels. That's what you're checking to see whether it's safe to move there, and you can see them on the screen. So it's really easy to make that link between what's being checked to see whether it's a safe move and what's actually on the canvas. But you have to be quite particular about getting that grid set up at the right size and making sure that the step size of your puck matches the size of the grid. And let me just show you what can go wrong if you don't get that right. Let's say that in my sketch, rather than moving up and down by 20, I moved up by 40, or down by 40, or left by 40, or right by 40. Now, most of the time this is still going to work, right? So my puck still moves around on the screen, and if I try to move down here, I think it's going to tell me I can't move there. So I can't move down because that would move me down sort of into that the wall of that bottom room. And I also can't move up, but I can move through the door. Can't go through that one, but look there, I jumped right over the wall. And there, I've got the same problem. And that's because, if I go back to my overhead camera here, if I'm only jumping 20, I can guarantee that I'm always checking each grid each time that I move. But if I allow a situation where I can jump 40, that means I could be in this square one time, and I move 40 and I jump right over this middle square, and we never actually check that value as well. So if you want to take account of cases like that, you'll need more complex approaches to checking your walls. You need to check the in-between values, or maybe use another way of representing what are legal and illegal moves. But if you stick to the grid and make sure everything lines up, this one will work most of the time. All right, in the next video, what I will do is show you how to add some nicer graphics and still have this, this simple pixel walls technique working. Happy creative coding, and I look forward to seeing what you come up with this, and also hearing your suggestions for other things that we could try out.